Hi students, welcome to this concepts and snippets session. Today we are going to discuss one of the most fundamental chapters in chemistry, that is periodic classification of elements and periodic properties. Today I have taken the modern periodic table or the long form of periodic table. Modern periodic table is designed by Henry Moseley, and the periodic law is based on atomic number. Moseley proved atomic number is the fundamental property of an element which decide chemical and physical properties of elements. Okay, so let us discuss the modern periodic table briefly, and we will do a simple question. Okay, the modern periodic table, also called the long form of periodic table, it is based on atomic number. Okay, the modern periodic table is based on atomic number from his studies on the frequency of X-rays emitted by different elements when irradiated with fast moving radiations. Moseley proved there is a relationship between the characteristic X-ray emitted by each element to its atomic number, not atomic weight. So he concluded atomic number is the fundamental property of any element. Thus, the modern periodic law says what? The modern periodic law states that physical and chemical properties of elements, physical and chemical properties of elements are periodic functions of their atomic number. This is the modern periodic law. Thus, in the modern periodic table, we have 18 vertical columns called groups in which elements with the similar properties are arranged. You see, I have taken a modern periodic table in which you have 4 different colors are shown. The light blue color shows the S block elements. You see, this is the S block elements of group 1 and group 2, also helium of group 18. It is based on electronic configuration. Properties wise, helium should be along with the noble gases, but configuration wise, it is S block. And you have the P block elements, which are on the extreme right side of the periodic table, and the group number is from 13 to 18. There is the P block. You have the P block elements. Okay, remember, helium belongs to S block, and in between the S block and P block, you have elements called transition elements. These are transition elements, or they are also called D block elements. Transition elements, which are shown in, you see, rose color. And at the bottom of the periodic table, I have, see, you can see in yellow color 2 series of elements called the F block elements, or the inner transition elements. Thus, in our modern periodic table, we have 4 blocks of elements based on electronic configuration. Okay, thus you have S block elements. You have elements of S block. Okay, you have elements of S block with electronic configuration, you see, NS 1 to 2. So, elements of group 1, 2 and helium of group 18. These elements have this configuration ns1 to 2, the distinguishing electron or the last electron entered into the s subshell of the outermost shell. Now you have the p block elements. Their electronic configuration is the outermost shell, the s subshell is completely filled and the electrons enter into the p subshell and the p subshell is progressively filled up to 6 electrons. You see, these are elements of group 13 to 18 except helium. Now you have D block or the transition elements. You know, S block elements are metals. In P block, majority of them are non-metals. So the D block elements represent a transition from metallic character to non-metallic character. And what the electronic configuration of D block? Here, the last electron enters into the D subshell of the penultimate shell. Penultimate means inner to the outermost. So the electronic configuration is, okay, it is the penultimate shell is getting filled up. So the outermost shell N has 1 to 2 electron, while the last electron enter into the penultimate N minus 1, where the D electrons are getting filled up from 1 to 10. These are elements of group 3 to 12. And finally, we have the F block elements are also called inner transition elements, which are shown separately at the bottom of the periodic table to avoid the unwieldy size of the table. So, here the last electron enters into the F subshell of the antepenultimate, inner to the penultimate. Thus, you see, the outermost shell N, S subshell has 2 electrons, and the penultimate N minus 1 shell has, D subshell has either 0 to 1 electron, and the electron enter into the N minus 2 antepenultimate, where the F subshell is getting filled up from 1 to 14. These elements are all F block elements belong to group 3. Their period is different. So, elements of group 3 and period 6, and period 6 is 4F block. There are 2F block, and period 7 is 5F block. As you know, in the modern periodic table we have 7 horizontal rows. So this is the very clear picture about our modern periodic table. Now let us do a simple problem. What is that? Which block of elements in the periodic table contains metals, metalloids and non-metals? Metalloid means semi-metals, elements having both metallic and non-metallic character. The only block which contain metals, non-metals and metalloid, it is the P block. The P block contains metals, non-metals and metalloids. For example, germanium, arsenic, antimony, polonium, all are belonging to P block. Clear now? Yes. So, example, germanium, arsenic, antimony and polonium, all are metalloids. All these elements are found in the P block. Okay, clear? Thank you.